We're going to look at example 2.6 today. The first part I'm going to go through and just kind of give you some extra explanation to make sure you understand why negative signs are where they are, why negative acceleration is so important, because I did mention that in the prior video. And so this is going to be one place where if you don't have your acceleration negative, you're going to have problems. Then I'm going to work the second half of the equation, or second half of this example problem, but I'm going to throw a twist into it so that it's not exactly the same as it was in the book. So if you already understood the first part of example 2.6, it's perfectly fine to fast forward through this first part of the video and watch the second part, but please do make sure you watch the second part so you can see what I'm going to show you there. Okay, so the first part of example 2.6, we're shooting a bullet straight up into the air with an initial velocity of 335 meters per second. We want to know the maximum height the bullet reaches before it falls back to the ground. So I know that initial velocity is 335 meters per second. I'm talking about the only thing that's going to be affecting that bullet once it's fired is gravity. So the acceleration, because acceleration pulls downwards, is a negative 9.8 meters per second squared. When the bullet reaches the top for a split second, the velocity is going to be 0 because it has to change direction. It's got to stop moving upwards and start falling back downwards again. So at that brief moment, the velocity is going to be 0. And the question was, how far does the bullet actually go up? So the best way to solve this one, v squared equals v sub 0 squared plus 2a delta x. So my v is 0. My v sub 0 is 335 meters per second, quantity squared, plus 2 times negative 9.8 meters per second squared times delta x. Okay. This is where negative acceleration becomes key, because if you don't make this negative, you're going to end up with a mess here in just a second. Let me show you what I mean. When I square this, I get 122,225 meters squared per second squared. And when I move it to the other side of the equation, it's going to be negative. And then here I'm going to have 2 times negative 9.8 meters per second squared delta x. Now, when I divide both sides by 2 and by negative 9.8, negative divided by negative is going to give me a positive number here, which is what I need. If I didn't make this negative, if I had left this acceleration due to gravity positive, my final displacement would have been negative. And if what we said was, if initial velocity upward is positive, but you say that it's going to have downward displacement, well, that doesn't even make any sense because it was moving upward, so the displacement has to be upward, not downward. So because it's moving one direction, but the acceleration due to gravity is the other direction, they have to be opposite signs. So it's crucial that this number ends up being negative. Okay, so when I divide that out, I end up with 5,700 meters for my delta x. Okay, so now we're going to look at the second part of the problem. They have a physics student throwing a rock upward off the side of a bridge and timing how long it takes for it to go up till it comes back down and then till it hits the water. And what I want to do instead is let's pretend that the initial velocity is still the same as it was in the problem. So the initial velocity is going to be 2.3 meters per second squared. Let's say that obviously my acceleration is still going to be the same, negative 9.8 meters per second squared. Let's say that this time I already know the height of the bridge. So delta x, because it's going to fall below the bridge and into the water, the displacement is going to be negative. So the displacement is a negative 0.4 meters. And let's say that now instead I actually want to calculate the time. Okay? Again, slight difference from the way that they worked this problem here, but I'm going to reword the problem to make it just put a slightly different twist in it because there's something really important I want to show you here. Okay, so what seems to make sense is that I would want to use delta x equals v sub 0 t plus 1/2 at squared, okay? So when I do that, and I plug everything in, I'm going to have a negative 0.4 meters plus v sub 0 is 2.3 meters per second times t plus 1/2 negative 9.8 meters per second squared times t squared. So now all I have to do is solve for t. Do you see a problem? I see a problem because I have both a t and a t squared. How am I going to solve for that? You have to use the quadratic equation. Who wants to use the quadratic equation? Well, in this case, you don't have any other option. You have to use the quadratic equation. That's the only way to solve for t. So in order to do this, I'm going to rearrange this so it's in the form ax squared plus bx equals c. You remember that from algebra, I hope. So I'm going to rearrange this, and I'm going to put this on the other side. So what I'm going to end up with is I'm going to move everything to the right-hand side. I'm going to put the t squared first, so I'm going to have a negative 4.9 meters per second squared t squared plus 2.3 meters per second t plus 0.4 meters. Okay, now if you recall, the quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a, right? Hopefully that rings some bells. Hopefully you remember how to do that. So when I go and plug this in here, what I'm going to have is negative b, here's my b, so I've got negative 2.3 plus or minus the square root of b squared, so I have 2.3 squared minus 4 times a is negative 4.9 times c is 0.4 all over 2 times a. Okay, so when you plug that into your calculator, you will come up with 2 answers, because remember, one time you do it and you're going to use the plus sign, the other time you use it and you're going to use the negative sign, so you come up with 2 answers, and t is going to either be equal to negative 0.14 seconds, or it's going to be equal to 0.60 seconds. Again, because a negative time doesn't make any sense, this answer doesn't make any sense, so my time is going to be 0.6 seconds. Now, let's say that you really don't like using the quadratic equation. I mean, who does? It's messy. Who wants to do that? So is there another way to solve this problem? Actually, there is. So let's look at what that alternate way would be. So we're going to get rid of this. This is why I mentioned to you a couple of videos ago that there's more than one way to work a problem, and sometimes you might choose to use 2 equations in place of 1. Because if you don't want to use a quadratic equation, let's see if we can find another way to do this. So I could start out by using v squared equals v sub 0 squared plus 2a delta x. I could start out with that equation because I know v sub 0, I know a, and I know delta x, right? So I could find what v squared is. So v sub 0 squared is 2.3 meters per second. I don't know why that's got a squared sign on there. Meters per second, quantity squared, plus 2 times negative 9.8 meters per second squared, times the delta x of 0.4 meters. And so when you solve all that, you end up with a v squared of 13 meters per second. Okay? Now remember what we said, whenever you take the square root of a number, it either has to be positive or negative. And so when I solve for V, I'm going to have V equal either to plus or minus 3.62 meters per second. Well, this time, how do I know which one is right? Well, I have to use the negative answer because my final velocity, if I've thrown the rock up, that was positive. Now the rock is coming back down, and so the velocity is in the opposite direction that it was before. So now I need to use the negative 3.6, and I'm actually only going to have one significant figure because of this. I'm going to have to use the negative 3.6 because that's the only thing that's going to make sense, because now my rock is falling, and so that velocity is in the downward direction. It's in the same direction as my acceleration is. So now that I know that, now I can take this and I can use V equals V sub 0 plus AT. I'm going to use negative 3.6 meters per second. Initial velocity was 2.3 meters per second plus acceleration, negative 9.8 meters per second squared times t. And then I will end up, again, once you solve that, you're going to end up with 0.60 seconds, which is the same answer that I got before. I got that same answer when I used the quadratic equation, but this way I did the same problem without using the quadratic equation. So this is what I alluded to earlier when I said sometimes you might choose to use two separate equations in place of using just one. And in this case, you did it because you were trying to avoid using the quadratic formula. There's nothing wrong with using the quadratic formula. If you feel comfortable with it, go for it. If you'd rather not, sometimes there's a way to get out of it. Sometimes there isn't. So you just have to be prepared and remember that piece of your algebra for when you do need to use it.